This is called function notation when f of x is just the same as y. It looks more confusing, but just think of it as y. You'll probably start seeing it more and more in this format. When are these statements true where y is equal to x squared? Well, 0 is equal to 0 squared. 1 is equal to 1 squared. 2 is equal to 2 squared, which is 4. 3 is equal to 3 squared, which is equal to 9. So this statement is true. The statement above is true, this quadratic, for all of these values. Parabola and an exponential function would be a more accurate representation of acceleration. But because we're familiar with this function, I decided to use this. But what if we wanted to find out what the speed is at 4 seconds? What the change in speed is at exactly 4 seconds? Okay, take that back. We're going to make it 2 seconds. So we want to know what the change in speed is at 2 seconds. Well, we already established that at 2 squared is 4, so it's going to be at 2, 4. So if we want to find what the change in speed is, try to consider what we're actually looking for in speed at the point that's 2, 4. So to determine that, change in speed over the change in time. And this might start looking familiar to you, in that we're looking for the change in y over the change in x. And we've been over this when we were graphing straight lines. This is the gradient. So what we're trying to find is the slope or the gradient right at this point. So at the very instantaneous moment when it's at 2 seconds, we want to see the change in speed. And it is the gradient of the line that touches this graph at that one point, that very one point, just 0.24. Looking at is the instantaneous rate of change at a certain point, at a certain time, which we decided was going to be 2 seconds. But the point is at 2,4. Instantaneous rate of change is equal to the gradient of the tangent line. So if we find the gradient just where that line skims that parabola at that one point, that's going to tell us how quickly the acceleration is changing. Or as I said it before, speed, but it is an acceleration curve from the perspective that we're seeing it.